Hi, this is your girl Rosie. I am so happy to be with you today. And today we'll continue from where we stopped in our last lesson. Okay, we'll continue from where we stopped in our last lesson on why for the mathematics questions 2024. I hope you're with your writing materials. Alright. So we are using the trapezium rule with 7 ordinates to evaluate this integral here. Okay, so first let's find the 7 ordinates. Remember, trapezium rule is a method or technique we use to approximate the area under the curve. That's a topic for another day. Now, for us to get the 7 ordinates, we need to divide the vertical lines into 7 equal spaces. Okay, so how do we get this spaces equal? We find the hedge, that's the width of the sub intervals by taking the range of those interval given to us. We are moving from 2.4 to 3.6. Okay, that's the range given to us. So we'll take it and divide by 7 to get our 7 ordinates. So here I have my 7 ordinates. Remember, you must start from 2.4 and end in 3.6. So in between now, we'll be adding 0.2 to get the other points. Okay, the other ordinates. So I have my 7, 1, 2, 3, 4, 5, 6, 7 ordinates. So for x equals 2.4, I'll have this. Substitute here and work it out. We do the same for others. Okay, so now the next thing is to apply the rule, the trapezium rule, that states that area can be calculated thus approximately. Remember, h over 2, open a bracket, have your function of the first ordinate, okay, double the second ordinate function, same thing, the third one you double it, okay, same thing with the fourth one, you double it. In fact, you double all except the first and the last. Okay, you double all except the first and the last. So if whatever number of ordinates you're working with, double those in between except for the first and the last. So get that noted. Okay, you double others except the first and the last. So almost done here. Okay, so the last and the first are the one you will not double. I will not double my number 1 function and the last function. Okay, so when you are done, you now substitute. So I have it here. Okay, so we can see the 2 that are not doubled, I have them together so I can add easily. So factor out 2 and get the other ones inside, then add. Okay, now add and then do my multiplication, 0 point divided, so that you can get it. Divide 0.2 by 2, you have 0.1, then multiply out and you have 0.4661. So remember, your answer should be in 3 decimal places. So to work that out, very easy. So we now have our final results in 3 decimal places. So this is how you use the trapezium rule. Okay, so look at it. I say it's the only ones you will not double are the first and the last function of your ordinates. Okay, thank you. So we'll go to the next, that's number 4. We are asked to find the equation of normal to the curve, and our curve is a quadratic curve at x equals 2. So with that known, so first thing to do is to find the value of y when x is 2, and that's we'll do. I did, and I have minus 6. So after which we find the slope of the tangent, slope of the tangent to the curve, slope of tangent to the curve. Tangent is a line that cuts a straight line that cuts the curve at a point outside. Okay. So find the slope of tangent to the curve. How do we do that? By taking the derivative of the function. So derivative of y. What is the derivative of y? So y dx, and that is 7 minus 10x. So we find the value at x equals 2, and that is minus 13. Now we'll now find the slope of the equation of the normal to the curve. Okay, so to find the slope of this is the slope of this is the negative reciprocal of this. Okay, the negative reciprocal. So the negative reciprocal of tangent to the curve is the slope of the normal to the curve. Okay, so knowing that, we are almost done. Okay, so this is it. So this is the M2 is the slope of the equation of the normal to the curve, and which is the negative reciprocal of the slope of the tangent to the curve, and that is minus 1 over M1. And our M1 is minus 30, so it's minus 1 over minus 13, which is 1 over 13. So we now substitute all these to the format for the equation of the normal to the curve, and this is the format. So here our y1, which is the y at x equals 2, is minus 6. Okay, and our x1 given is 2. Okay, then our slope, our slope of the equation of the normal to the curve, which is the negative reciprocal of the slope of tangent to the curve, which is 1 over 13. So all this well substituted, will now have this equation here, and then we'll now open the brackets and have our final answer when you have collected them all on one side of the equation and equal them to 0. Okay, this is our equation of the normal to the curve. So try it out and let me see what you have. Any question, drop it on the comment section and it will be attended to. Love you all and bye bye.